Hi everyone and welcome to Physics with Mr. Simons. In today's lesson we're looking at Newton's laws and I'm starting off as basic as I can. I'm looking at a single body that's pulled at the angle, so we're applying a force at the angle that's given to you. Right, but I'm going to go through the Newton's laws problems. I'm going to do each video is going to be on a variation of it. Right, so hopefully if you watch through all of them, you can master mechanics and get used to how we change the questions trying to catch you out. So without further ado, let's look at the question. Right, the 10 kg object is pulled towards the east with applied force of 60 newtons. So there, we're applying a force while pulling this 10 kg object. We will always have friction that acts against the 10 kg. Right, so first question, generally, even if they don't ask it, get in the habit of doing it. It will allow you to understand in which direction my forces are working in the X and the Y direction to ensure we can simplify it. So one, can you draw a free body diagram showing all forces acting on a 10 kg object? Alright, determine the horizontal and vertical components of this applied force. So when we say that, we assume you know there's a horizontal component and there's a vertical component of applied force. Determine the magnitude or the size of this frictional force here, given that mu k, coefficient of kinetic friction, is 0.28. And then we want you always, basically with Newton's laws, if we're working with Newton's second law, can you determine the acceleration of the blocks? And as you can see, that's 4, 8, 12, 17 marks, one small simple problem. As I said, you can pause here, work through the problem, see what you can answer. But in general, as I say, we're not going to straightforward ask the same thing all the time. Most of the time when you study, you don't study the variations and we catch you out. So please, after watching this video, you can go watch the next video where the angle would be left out and now we're testing, can you find the angle? I want to make sure you master all these variations so you become a master in mechanics. Right, so number one, draw a free body diagram showing all forces acting on a 10 kg object for 4 marks. So generally when examiners say 4 marks, that means we have 4 lines. So number one, the 10 kg object is resting on the surface. There's gravity that's pulling it down, but it's not moving. Therefore, we have a normal force that's acting up against it. So the normal force and the force of gravity, they balancing each other out. Not totally, but yeah. Then we have friction. That always acts opposite to the direction I'm pulling or applying a force. And there's my applied force. So 1 mark for each one drawn properly. In reality, I have force of gravity, normal force, and my applied force is a y component. So the y component plus the normal force must equal my force of gravity. Right? And we catch learners out because somehow, I don't know, it gets stuck in your head over the years teaching physics that learners always naturally assume that force of gravity just equal normal force as drawn there. Alright? In this case, because my applied force is at the angle, it has an x component and a y component. So the y component plus the normal force must equal force of gravity. So please don't get caught out of that. Alright? Then my applied force in the x direction is what's allowing me to accelerate the object. And this must be greater than my friction to ensure that the object is moving. Right? So I hope you understand. And when we say 4 marks, basically we want 4. Vectors drawn. So you can see there's a vector. I have an arrow showing directions. If we draw these 4 vectors, 1 mark for each one. Right, now let's go look at the next question. Determine the horizontal and vertical components of applied force. Right, so if we take the applied force, there's my applied force. You can see there's my horizontal component or my x component, and there's my vertical component, right? There, theta is my angle, 40 degrees, right? So we assume you remember cos theta equal adjacent of hypotenuse and sine theta equal opposite of adjacent, or so to 1. Assume you remember that, right? So whenever we want the horizontal component, it will always basically end up being cos, because horizontal is adjacent over hypotenuse. So FAX would equal FA cos of theta. FAY, that is opposite, as you can see, of hypotenuse. Opposite of hypotenuse is sine. So therefore, y, FAY equal FA sine theta. As I always joke around, why do you sin? Right, so for basically all my Newton's problems, there's a pattern, and you'll see as I go through the other videos, where the x component is always cos and my y component is always sine. The only time it changes is when the object is moving up and down an incline. But we will get to that later on. Alright, so yeah, my applied force was 60 newtons. I substitute in. My angle is 40, cos 40. That gives me 45,9627 newtons. Or if we round off, 45,96. Alright, 2 is too small to change 6 to 7. Same this side, my applied force is 60. And I have sine of 40 degrees, which gives me 38,5673 newtons. Or 58,57. The 7 changes 6 to 7 if you round off to 2 decimal places. Right, most of the time we only round off in the final answer to make sure we don't make an error along the way. But yeah, if they say 2 decimal places, that is what you would round off to. Right, now let's look at the third problem. I hope you understand. So as I said, x will always be with cos and y will always be with sine. Why do you sin? Alright, so that's just a basic pattern. Let's look at the next problem. Determine the magnitude or the size of the frictional force, mu k. Alright, so we want friction there. So to get to friction, I need to get normal force, right? But a normal force doesn't equal force of gravity. So this object, the 10 kg, is not moving up or down, but it's moving horizontally across, right? So my forces in the y direction is balanced. So therefore I can say F net equals 0 for my y. Forces in the y direction, right? So my normal force plus my force applied in the y direction must equal my force of gravity, right? Now from there, if I take force of gravity, it would be 10 times 9,8 gravitational force. The force applied in the y direction we solved in the previous problem was 38,5673. So that gives me 98 minus that gives me 59,4327 newtons. For that, 1 mark for understanding that it's normal force not equal to force of gravity, but normal force plus the force in the y direction equal force of gravity, 1 mark. Substituting my values correctly, 2nd mark, and getting the correct answer with the SI unit. No? We must put newtons. Get 3 marks. Now, for friction, the equation will always reach friction equal mu k, my coefficient of kinetic friction, times my normal force. So mu k was given as 0,28, and my normal force there, 59,4327. Multiply out, my frictional force is 16,6412 newtons. So there, another 2 marks. So all in all, 5 marks. So force of friction, 16,64. Alright, so I hope you follow and understand what I've done. Don't get caught out to this. You'll see how many times I'm not do this. It's one of the key problems we use, especially here. In our past exam papers, grade 11 and 12, we catch you out where you forget that the y force also affects the normal force. Alright, let's look at question number 4. Alright, now ultimately all Newton's problems, especially second law, should end up where they say determine the acceleration of the blocks. So Newton's second law says my forces in the net direction must equal my mass times my acceleration, or F equal to ma. Right, so F, we got the friction is 16,6412 newtons. We got the applied force in the x direction as 45,96 newtons. According to Newton's second law, force equal to mass times acceleration, right? So my net forces in the x direction, as you can see, I have FAX going to the right, I have F going to the left. Those two are going in opposite directions, so I'm going to say FAX minus friction, if I take to the right as positive, equal ma. Alright, so 1 mark for those two. If I substitute the values, 45,96 minus 16,6412, and my mass there was 10 kgs, so that becomes 10A. 45 minus 16 is going to give me 29,3215 equal 10A, and if I divide by 10, I'm simply shifting that comma one space, so it becomes 2,93215, or rounded off to 2,93 meters per second squared. Right, and there we found the acceleration. So 1 mark for correctly specifying Newton's second law, F net equal ma. Another mark for correctly putting in the correct forces as per my diagram there, substituting the correct values and getting the correct answer. Right, so I hope you understand. So this is the easier version of Newton's laws, just working with one body. What I've done here eventually will become two equations, or simultaneous, when we have two bodies attached. And I have two bodies that's being pulled, or we're going to have two bodies where one hangs with the other one, and we have to solve it simultaneously. Right? So as I say, I'm grateful that you are here. I'm grateful that you understand. Right? Continue practicing, and I'm going to continue uploading videos till such time that you've mastered this topic. God bless. Bye.